Hello everyone, welcome back to Kubernetes Zero to Hero series. We'll see Kubernetes config maps explained in 10 minutes. Have you ever hard-coded a database URL, API endpoint, or application configuration inside a pod? What happens when that configuration changes? Do you rebuild the image every single time? So we have a solution for this. It's called as config maps, and in this video I'll show what exactly config maps are, why they are important, and how they separate configuration from application code. So let's get started. Problem without config maps. The problem was that you have an application running in Kubernetes. You hardcode values like database host, environment name, and API endpoints. Everything is working fine. But now something changes, and now you have to modify the YAML file, redeploy application, and sometimes rebuild images. As applications would grow, managing configuration will become a nightmare. So this is the problem that config map will solve. And what is a config map? A config map is a Kubernetes object, and it is storing the configuration data separately from the application ones. It's like settings file for application. So instead of embedding configuration inside the container images, we are storing it in Kubernetes in the form of config maps. Config maps can store variables, environment variables, URLs, ports, application settings, configuration files, and they are less sensitive data. So this makes the application more flexible and easier to manage. How it works? First, we create a config map. It will store key value pair such as a database host equals MySQL service or database port equals 3306, app environment equals production. Now when the pod starts, it reads these values from the config map. The pod does not need to know where the values are coming from. It simply assumes, and this separation of configuration and application is the best principle of cloud native design. Now how to create a config map. Let's create one. We define it. We define a config map called app config, and then in the data section we are storing app environment, database host, database pod. Where once the YAML is ready, we will execute using commands kubectl apply and kubectl get config maps. kubectl apply configmap.yaml will verify whether it's created, and kubectl get config maps will verify whether it is stored independently from the application. How to use it? Use cases is ingesting config map values as environment variable. So inside the pod definition, you can have a reference specific key like app environment can be read from the config map, and when the container will start, it will automatically receive the information like app environment is equal to production. So this application will read the value just like any normal environment variable. No code changes are required in such situations. How will load the entire config map? If config map contain dozens of settings, importing them one by one would be tedious task. So instead of that, we have um, a, like we have a process in which we can load the entire config map. So using an envfrom, that is environmental from, every key become an environmental variable automatically, and this is useful in large enterprises application that may have many configuration setting, less YAML, cleaner deployment, and easier maintenance. Now, what is mounting of config map as files? So every application would not use environment variable. Some application accept configuration files. For example, application property, config.yaml, and nginx.conf. So Kubernetes is giving us flexibility to mount config maps directly as the files inside the container. So the config map becomes a volume. This is volume is mounted inside the pod, and the application will read the file exactly as if it existed on the disk itself, and it is a very popular pattern in production environment. Let's quickly see a real world example. Front-end service needs API URL, backend needs database host, and payment service needs payment mode. Instead of hard coding these values in applications, all configurations stored in ConfigMap. Benefits will be easier update, reusable Docker image, better environment management, and cleaner deployments. Now we'll see the difference between secrets and ConfigMap. One of the most important interview question. Config maps are for non-sensitive data, secrets are for sensitive data. Example config maps are URL, ports, environment names, but secret will have the API keys and password and tokens stored in it. And this is information is critical and confidential. So always use Kubernetes secret. So in the next episode, we'll learn exactly how Kubernetes secrets work. Now you understand config maps are why they important. This is a fundamental Kubernetes concept and something you'll used almost every day. If you find this video useful, hit the like button, subscribe to the channel, and turn on notifications so you don't miss the next episode on Kubernetes secrets. And before you go, answer this question in comments. Have you ever hard-coded configuration values in an application before? I would love to hear your experience. Thank you for watching, and I will see you in the next Kubernetes Zero to Hero episode.